Welcome to the video lecture for section 9.2. This is for MGF 1106. My name is Jorge Young, and this is polygons. So we are going to talk about the first three objectives. The last one we'll talk about it in class. So in this lecture, we're gonna go ahead and be introduced to basic terminology and properties of polygons. We're going to solve problems involving polygons, the angle relationships of polygons, and then we're going to use similar polygons to solve problems. So a polygon is simply a plane figure is closed if we can draw it without lifting the pencil and if the starting and end points are the same. A plane figure is simple if we can draw it without lifting the pencil, and in drawing it we never pass through the same point twice, with the possible exception of the starting and ending points. So the first one is a closed and simple. The second one is simple but not closed. The third one is closed but not simple. And then the last one is not simple and not closed. So a polygon is a simple closed plane figure consisting only of line segments called edges, such that no two consecutive edges lie on the same line. We call an endpoint of an edge a vertex, the plural is vertices, and a polygon is regular if all of its edges are the same length and all of its angles have the same measure. So here in A, this is not closed. A, the second A is not simple, not closed, and then the last one is not made of line segments, so that's not a polygon. For B, the first B on the left is non-regular polygon, sides are not the same. And then the last one on the bottom right-hand corner is regular polygon, sides are the same length and angles have the same measure. So we classify polygons according to the number of their sides. And so here's a table. We'll mostly be dealing here with perhaps 3 and 4, maybe 5 sides, although there will be examples with polygons that have 7, 8, 9, or even 10 sides. So a polygon is convex if for any 2 points x and y inside the polygon, the entire line segment xy also lies inside the polygon. So you can see here on the left hand side was convex, and on the right hand side was not convex. Now we're going to talk about triangles. Triangles are scalene triangles, no sides are equal. An isosceles triangle, at least 2 sides are equal. And in an equilateral triangle, all sides are equal. Now, quadrilaterals, we have trapezoids, at least 1 pair of parallel sides. Parallelogram, 2 pairs of parallel sides. A rectangle has 4 right angles. A rhombus, all sides are equal in length. And then a square where all sides with 4 right angles. All sides are equal with 4 right angles. So here's an example. Find the sum of the measure of the interior angles in triangle ABC. So we begin by constructing line M that contains a line segment AC and a second line L through the point B that is parallel to M, as shown here in this figure. Now, because angles 1 and 4 are alternate interior angles, they're equal. Similarly, angles 3 and 5 are equal. Therefore, the sum of the measures of angles 1, 2, and 3 equal the sum of the measures of angles 4, 2, and 5, which is 180 degrees. Now, this example, we're going to find the interior angle sum of the convex pentagon ABCDE. So we already know that the interior angle sum for a triangle. It makes sense to divide the pentagon into a collection of triangles, as shown in the next slide. So each triangle has an interior angle sum of 180 degrees. So the measure of angle A all the way through the measure of angle E is going to be equal to 3 times 180 degrees because we have 3 triangles, which is 580 degrees. So triangle, number of sides are 3, interior angle sum is 180 degrees. Quadrilateral, number of sides is 4, interior angle sum is 360 degrees. Pentagon, number of sides is 5, interior angle sum is 540 degrees, which is 3 times 180 degrees. Now, angle sum of a polygon. The sum of the measures of the interior angles of a convex polygon having n sides is n minus 2 times 180. The interior angles of a regular polygon. Each interior angle of a regular polygon with n sides has a measure of 180 times n minus 2 over n. Now, 2 polygons are similar if the corresponding sides are proportional and the corresponding angles are equal. And that's the end of section 9.2. Thank you.